Welcome to Science Extension, the Foundations of Scientific Thinking, Module 1, and we really are building our foundations from the bottom up, starting with epistemology, which is the theory of knowledge. How can we know something? What are the methods of knowing something? How do we know if knowledge is valid? And to what extent can things be known or can things not be known? And what's the difference between something that's a justified belief and an opinion? And they want us to start off by discussing alternative ways of knowing, for example, the development of navigation. So development of navigation by Polynesians is an example of traditional knowledge. So we can compare traditional knowledge, compare that to science, for example, scientific knowledge. So this example of traditional knowledge is where Polynesian navigators used a bunch of different things. They used observations of birds in the sky or stars, winds and waves in order to navigate, right? So if they were trying to go from one island to another and they wanted to know what direction to go, they might look at the stars and measure the stars, if you've seen Moana, or if they want to know if they're heading in the right direction, they might feel into the water and feel if the current's going in the right direction or if they're the right temperature. And by measuring these things and by comparing them to their traditional stories and songs, they would know if they're going the right way or not. Okay. Scientific knowledge is knowledge that has a lot of explanations and has experimentation and knowledge that is repeatable by anyone, anywhere. Now, all of these things are not in this traditional knowledge. There is no explanation as to why the winds and the waves were in a certain direction or why the stars were there. There was arguably there was a lot of experimentation actually, probably to come up with this traditional knowledge. No, not experimentation. What there was in traditional knowledge instead of experimentation was observation. A lot of detailed observations over many, many years. Instead of explanations, they had their traditional stories, which they had their stories and songs. And instead of being repeatable, they were definitely not repeatable in different locations. They were very specific to one area, maybe even a particular time in an area. So they weren't very scientific at all. And you would say that the Polynesian navigators in 900 BC had no scientific understanding. However, did they have knowledge? Yes, they had very sophisticated knowledge. They knew exactly where they were and they knew where they were going and how to get there at any point in time while navigating. And they did it much better than anyone else. By 900 BC, they had traveled 6,000 kilometers into the open ocean to get to Tonga, Samoa, and a few hundred years after that, they'd gotten as far as at least Hawaii and Easter Island, possibly to South America. They'd gone as far south to get to New Zealand, and they had gone to Madagascar as well. Whereas at the same time, the rest of the world were too afraid to go out into the open ocean because they'd get lost. And so instead they stayed close in sight to land. It makes sense that you do this. If you were a Greek in the Mediterranean, you're essentially sailing in a body of water that's surrounded by land rather than the Polynesians who live on land surrounded by water. If the Polynesians tried to stay inside of land, they wouldn't get very far trying to travel away from Tonga. Okay, so alternative ways of knowing are still valid knowledge, but they're not scientific. There is no explanation behind their way of knowing. Traditional knowledge is detailed and specific because it's trying to achieve a purpose, right? they don't need explanations because the explanations don't help them with their particular purpose. They're trying to navigate. They don't care about why water moves the way it does. What's important is where you go and how you get there. Whereas science makes models which are simplified. However, by simplifying them, you can make them repeatable to different areas, and maybe you can work out how. Maybe you can learn. You can use one bit of scientific knowledge in an area that you never thought you could. The ancient Greeks who were rubbing amber against cats in order to see static electricity probably never imagined the power grids that give electricity to all of us in our world today. Break to draw a cat. Okay, so that's the development of navigation. That is one alternative way of knowing, not a scientific way, but it's one way of knowing that is still valid. And it's important for us to understand what science is and what it isn't, to admit that science is not everything that is right. Instead, it's just everything that we can show evidence for using the scientific method. There are some questions that we haven't been able to answer yet using science. And I say yet, even though there are some questions we can probably never know the answer for using science. But also, there are some questions that we didn't know in the past which we have since been able to answer using science. So, science isn't all knowledge. Also, I want to point out another idea that people have had between traditional and scientific ways of knowing, which is I've heard people say that science changes while traditional knowledge doesn't. But there have been examples in the past where this hasn't been true. For example, the Indigenous Australians in the Northern Territory have Dreamtime stories about the cane toad. The cane toad has only been there for, I think, 50 years roughly. So their traditional knowledge is changing and adapting to what's changing and adapting in their world. The Pope released a statement about climate change. It was an interpretation of the Bible to say that it's our responsibility to avoid climate change because the earth was given to us, it's ours to look after. And climate change definitely wasn't an issue in traditional Christian culture, in their traditional knowledge. And the opposite is also true. Within science, there's plenty of things that have not changed despite large amounts of evidence, or it took a long time for them to change, such as our understanding of plate tectonics, which we'll get to in a later dot point in this subject. Okay, so some very, very different fields, traditional and scientific knowledge. Let's look more at how scientific knowledge progressed, and even within science, there are alternative ways of knowing. So the idea of skepticism arose, which is that you cannot trust your senses. Everything that you see could be an illusion, so we can't really know anything for sure. Okay, because all knowledge comes from your senses, right? I can see my computer in front of me, so I know it's there. However, do I know that my sight is correct? Do I know that my mind is actually interpreting my sight correctly? Do I know that my mind exists? Am I real? Right? If I don't know the answers to those questions, do I know that the computer is there? Not really. That is skepticism, the idea that no true knowledge is possible. That's a pretty useless idea, honestly. If no knowledge is possible, what's the point of anything? So there were two main camps that sort of diverged from skepticism in order to try and answer it, to try and find ways of knowing. One of them was rationalism. And this is that knowledge can come from thought. If we can use thought and logic, logically we can create knowledge that is true. And from this we get René Descartes' famous cogito ergo sum, or I think therefore I am. The argument was that he's thinking, and if he thinks I exist, right? And if he's being tricked into thinking he exists when really he doesn't exist, well, that means he's being tricked by something, and something is being tricked, right? Either way, he exists. He exists if he's correct, he exists if he's incorrect. So that was rationalism. Now, some people said that after you say, I think, therefore I am, you can't really get very far after that because the mind can be wrong. So the other, and I would say more useful, route in philosophy was empiricism. Now, I say it's more useful with a lot of bias towards science because this really led towards a lot of scientific discovery. Because empiricism is saying that we can get knowledge based from our senses. I'm going to say the 5 senses of taste, smell, sight, hearing, and touch, but we know there's many more senses than that, such as the sense of how full you are after a big meal. But knowledge is derived from the senses. Now, there was a lot of argument against this as well, such as the senses can be tricked. Is your experience red the same as mine? If they're different, if I see this color here, I see this as red, you see this as red, but are we really seeing the same thing? Maybe to you, this is what I call blue, but because everything pointed out to you has said, this is red your whole life, you call it red even though you see it as blue, I don't know. And so this led to people saying, well, there are some qualities of objects which are true qualities and some which are subjective. So, for example, I've got my phone here, right? And you could say that it's got a certain color, right? I would say that it's, purple to blue on my phone. And that could be subjective. But the size of the phone and the weight of the phone, those are objective things that we can measure and we can agree on every time. We might disagree on the color. What type of blue is this? Is it sky blue or azure or whatever? But we're not going to disagree if we weigh it on the weight of the phone. And then there were arguments against that from rationalism to say that, well, can you imagine a phone with no color? You can't. We can disagree on how the phone feels as well. I can say it's smooth, but you could say maybe it's a bit sticky. But can you imagine a phone with no texture? So this phone that exists, can it have mass and size? Can it have those things without also having color, texture, sound, taste? Perhaps not. So there are still ongoing arguments between rationalists and empiricists, but the way science has progressed has been using empiricism, but saying that, yes, your senses are the most reliable source of knowledge. However, they can be tricked, and so we must also try to look at what sense data is reliable and what sense data isn't. It's not as clear-cut as saying empiricism and senses are always correct or thought is always correct. It has to be a little mix of both. Okay. Hopefully you've got a basis of knowing what is truth and what isn't, or at least how to identify what truth is and what isn't. Next time, we'll look into a bit more on how to actually know if your senses are true or not, or how to actually know if your thoughts are rational